point in this chapter. We have started off with wave optics. In this chapter, we are focusing on the wave nature of a light. We have seen three different types of nature. We have seen corpuscular nature, as in light as a particle. We have seen wave nature, and we have seen dual nature, wave particle duality. Out of that, we focus on wave nature of the light. In that, the principal scientist who was behind the wave nature, Christian Huygen. We have already seen Huygen's theory of light. We have seen the characteristics, disadvantages, advantages of it. We have seen what do you mean by wavefront. Three types of wavefronts which we have seen: plane, spherical, and cylindrical, focusing more or less on the progress of plane as well as spherical wavefront. After that, we have seen the laws of reflection proved with the help of wave theory of light. We have seen some additional mathematical part, some derivations ka part regarding this. Then we have seen superposition of waves, and the part where we started was the interference. In interference, we have already started with the basic, we have already completed with the basic concept about interference. We have studied about coherence, coherent sources, and we have started off with Young's double slit experiment. We have already understood that particular experiment. What happens in this particular experiment? Something like this. We get an interference pattern which is formed on a screen. And what is that interference pattern? That interference pattern, in simple words, is the alternate dark fringes and bright fringes. We can call them as dark bands and bright bands consecutively. So this is the part where we left in the last lecture. Now we are going to analyze the geometrical part about this double slit experiment. So for that analysis of double slit experiment, what do we consider? That is the part which we have over here. Now we are going to take this diagram and we are going to modify it as per our requirement. Okay. So for that, this is the diagram which we are using. Now what do we have over here? S1 and S2, same as that of before. We have two sources, which are two slits to be precise, S1 and S2. We consider a midpoint of S1 and S2, which is point O. So O is equidistant from S1 and S2. And on the screen, we consider another point, O dash, which is again equidistant from S1 and S2. Now we consider this is our area of interest, point P, which is the any point P on that particular screen. So we don't know that particular point. At that particular point, which band is formed, whether it is bright band or dark band. वो हम लोग बाद में decide करेंगे. So this is any point P which is considered on this particular screen. This is the part of slits S1 and S2. Now the distance between slits and the screen is given by this D, capital D. So what is capital D? Capital D is the distance between slits and screen. We have small d over here. Small d represents distance between the slits S1 and S2, which is given by small d. We are going to encounter this later as well. And you can see y is the distance of point P from the origin. Now we can consider O dash as the origin on the screen and O as the origin of this particular slit. So now based on this, we are going to understand the basic geometry of this particular double slit experiment. So starting off with, we know O dash is equidistant from S1 and S2. And we also know from experiment that O dash is the point where the bright spot or bright fringe is formed. Means the constructive interference it takes place. अब ये कैसे पता चला? From experiment itself. Now we consider P is the any point on the screen, and we don't know what the phase at P will be, but we know that at P the phase will not be same. So from these two triangles, कौन से triangles है? S1, S1 dash and P. Look at this diagram simultaneously. This is S1, this is S1 dash and P. So this triangle S1, S1 dash and P, and second triangle we have S2, S2 dash and P. So this is S2, S2 dash and P. So these are the two triangles we are considering. So from this particular triangles, we can write S2P square minus S1P square. S2P square minus S1P square can be written as D square plus Y plus D by 2 का square, which is S2P का square, minus S1P का square हम लोग लिख सकते हैं D square plus Y minus D by 2 का square. अभी ये टर्म किधर से आता है? ये टर्म आता है बेसिक पाइथागोरस थ्योरम से. For S2P, I'll show you how it basically happens. This is what we have. Perpendicular. So S2P का square will be S2 S2 dash का square plus S2 dash P का square. Pythagoras theorem in that particular triangle. तो S2 और S2 dash का square मतलब क्या आएगा? D square. So we have D square over here. और ये S2 डैश और P का स्क्वायर मतलब इसका स्क्वायर, तो ये डिस्टेंस कितना होगा? ये डिस्टेंस कितना होगा कैसे पता चलेगा? P टू O डैश, ये Y है हम लोगों के पास, तो O डैश S डैश कितना आएगा? अगर ये टोटल D है and O is the midpoint of S1 and S2, means this distance we can say as D by 2. So if S1O is D by 2, means S2 dash O dash will also be D by 2. So that's why what do we get? S2 dash P, S2 dash P will be Y plus D by 2. And uska square, that's why we have Y plus D by 2 ka square. The same thing will be applicable in case of S1 dash as well. S1 dash P कितना आएगा? ये टोटल Y है, उसमें से ये माइनस करना पड़ेगा. ये कितना होगा? Again it will be D by 2. That's why you can see it is minus D by 2. बाकी कुछ नहीं है. Okay? ये स्टेप समझा रहे? बोलो yes or no. ओके गुड. सो इसको हम लोग जब सॉल्व करेंगे ये पूरा का पूरा, तो क्या मिलता है हम लोगों को? हम लोगों को मिलता है 2YD. इसको सॉल्व करेंगे मतलब क्या? ओपनिंग द ब्रैकेट, स्क्वेयरिंग, सो ऑन एंड सो फोर्थ. आई एम होपिंग यू विल बी एबल टू अंडरस्टैंड दैट. तो ये D स्क्वायर और माइनस D स्क्वायर कैंसिल हो जाता है. ओके तो ये ब्रैकेट हम लोगों ने ओपन किया तो क्या मिलता है हम लोगों को? Y स्क्वायर प्लस 2 इंटू Y इंटू D बाई 2 प्लस D बाई 2 का स्क्वायर. यहां पे भी ये मिलेगा Y स्क्वायर माइनस 2YD अपॉन 2 प्लस D बाई 2 का स्क्वायर. तो वो Y स्क्वायर कैंसिल हो जाएगा. D स्क्वायर D बाई 2 का स्क्वायर D बाई 2 का स्क्वायर कैंसिल हो जाएगा. YD and minus of minus YD will get 2YD. So what we will get? S2P square minus S1P square is equal to 2YD. Basic mathematics. A square minus B square. We can write A plus B, A minus B. So what we will get? S2P minus S1 and S2P plus S1 is equal to 2YD. But this S2P minus S1P, this is S2P which we have, minus S1P. ये S2P माइनस S1P को हम लोग बोलते हैं पाथ डिफरेंस. This is very important. Path difference means what? Difference between two paths. What is one path which we have? It is S1P. What is the second path which we have? S2P. So the path difference can be given as, when this S2P plus S1P goes on LHS, goes on RHS, it will be 2YD upon S2P plus S1P. Now it is not done yet. Any doubts till this point? Bolo re yes or no? Okay, good. Now we are going to move forward from here for, sorry. We are going to move forward from here for S2P plus S1P. Now, ये path difference जो है जिसको हम लोग बोलते हैं delta L. Okay, this is L, huh, by the way, small l. So this delta L का फॉर्मूला हम लोगों को अभी निकालना है path difference के लिए. वो कैसे? Let's see that. Now ये इसका कुछ तो भी करना पड़ेगा हम लोगों को S2P plus S1P. For that we have a specific condition. Now for d by d, small d by capital D, which is very less than 1. मतलब क्या है? Small d upon d, the value is very less than 1. Means ये जो distance है small d, the distance between the slits is very less as compared to the distance between the slit and the screen. Sorry. What we get? We can write small d is equal to capital D. So if we have small d which is equal to capital D, we can approximate it for d only. Just a minute. So for small d is equal to capital D means what? This d is very small. Either it is equal to capital D or we can ignore it. So for that particular value, what we can say that S1P is equal to S2P. And as the distance it goes on increasing, the d it goes on increasing. This line, instead of being it like this, we can consider it as a straight line. S1. So approximately S2P plus S1P can be considered to be 2 times that of D, approximately equal to, for a very large value of capital D. So what we will get? Going back up a little bit, what is the formula which we had for path difference? Delta L is equal to 2YD upon S2P plus S1P. But what is S2P plus S1P? Now we have 2D. So what we will get? Delta L is equal to 2YD upon 2D. So this 2 and this 2 will get cancelled. We are left off with YD upon D. Now keep in mind, this is for constructive interference. And obviously this is just for the one value which we have found out. Generalizing this equation, what we will get for condition for constructive interference is given as YD upon D. For n number of constructive interference, this is for number 1. For second one, what we will get? N के जगह पे हम लोग substitute कर सकते हैं value 2. So this will be Y2D upon D, which is equal to 2 lambda, so on and so forth. So this is the condition for the path difference, and this is the condition for the constructive interference. Path difference between two bright bands or bright fringes per se. Now yn क्या है? Yn is the position of nth bright fringe, where n it goes from 0, 1, 2, 3, both plus and minus. So we can modify the formula of delta n and we can write for yn as n lambda d upon d. And how to find out the nth bright fringe? मतलब if you want to find out 10th bright fringe कहाँ पे फॉर्म होगा, तो y10 will be n के जगह पे 10 डालेंगे, lambda big D small d, all of them they will be given. So this is the formula which is for nth bright fringe. Keep that in mind. This is for nth bright fringe. Any doubts till this point? Bolo yes or no? Okay. Okay, good. Now the way we are finding it for the bright fringe, similarly we can find it for the dark fringe as well. So what will be the condition for the dark fringe? Now for the nth dark fringe, the condition can be given like this. Once again, yn is for the dark fringe. Again, n goes from 0, 1, 2, 3, so on and so forth, both positive and negative. Keeping in mind, dark fringe is formed when the interference is destructive interference. This is very important. The interference is destructive. So what we will get? For that, we can write S2 minus S1, S2P minus S1P, which is delta L, the path difference, which is given as yn d by d, and n minus 1 by 2 lambda. That is the condition which we have for destructive interference. So the formula for yn can be given as n minus 1 by 2 lambda d upon d. Once again, keep in mind lambda kya hai? It's the wavelength of the incident light. Capital D is the distance between the slits and the screen. Small d is the distance between the slits itself. And yn, nth dark fringe. पहले bright था, अभी dark fringe है. Keep that in mind. Okay. The way we had it for bright fringe, similarly we have it for the dark fringe as well. Now, if we want to find out the distance between two fringes or distance between two bands for that matter, means what will be the distance between the bright fringe and the dark fringe, first bright fringe and first dark fringe, or distance between two consecutive bright fringes or dark fringes. That is what we call it as the fringe width or the band width. Band width भी बोल सकते हैं उसको, fringe width भी बोल सकते हैं, one and the same thing. Now, what is the fringe width? It is distance between two successive dark or two successive bright fringes. Now, keeping in mind the bands, they're equally spaced. So, whatever be the distance between two dark fringes will be same as that of two bright fringes. So, fringe width matlab kya? Distance between two fringes. So, if we consider one dark fringe which is formed at yn, so next dark fringe will be y of n plus 1. मतलब n अगर 1 होगा तो उसके बाद 2 आएगा, मतलब plus 1 होगा, उसके बाद आएगा 3 आएगा, plus 1 होगा. So fringe width denoted by W can be given as the difference between the fringes, which is y of n plus 1 minus y of n. So this is nth bright band or dark band. ये n+1 मतलब उसके बाद वाला ब्राइट और डार्क बैंड. So now we have the formula for yn, we can apply it for n+1 as well. Doing that, we get the formula W is equal to lambda d upon d, where W it stands for the bandwidth or fringe width, lambda is the wavelength of incident light, capital D is the distance between slits and the screen, and small d is the distance between two slits. Keeping in mind, most important formula which we have is fringe width, and most important concept which we need to remember, the bandwidth or fringe width is equal for bright and dark fringes. Means if the fringe width of dark band it's, let's say, 1 centimeter, then the bright will also be of 1 centimeter. So they are equidistant and their widths are equal. Any doubts till this point? Bolo re, yes or no? हाँ, Smita, doubt है? Okay. Okay. Good. Now, whatever formula which we have now, yn का formula, this is for dark fringe. चाहिए तो इसको dark fringe करके note down करो. YND बोलो if you are getting confused. So you can call it as YND और उसको YNB बोल सकते हो bright fringe के लिए if you are getting confused. So these two formulae and W, this is very important. We do use it a lot while solving numericals. And the similar formulae which we have, which are given next. Okay. Now, when we consider at point P, the phase is different. So how to find out that phase, or how to find out, to be precise, the phase difference? So the relation between the phase difference and path difference is given over here. I'm guessing we have already utilized that in wave motion. That time I told you that this is given in wave optics. So this is the relation which we have over here. So 2 pi by lambda into delta L. Again, we don't have to worry about the derivation of it. Just remember the formula. Once again, what is delta phi? Delta phi is the phase difference which we have. We have already established at point P that the phase is not same, it is different. So that phase difference is given by this delta pi. Delta L gives you the path difference, and lambda is the wavelength of the incident light. So for the phase difference, if we apply the concept for point P, then for point P, we can write the formula for phase difference. We can substitute this value of delta L over here from previous formula. So delta L kya tha? YD upon D. So on substituting that particular formula, the phase difference at point P from S1 and S2 can be used or can be given as delta phi, delta L ke jagah pe this formula which we have already derived, YD upon D and 2 pi by lambda as it is. Now, what is the condition for constructive interference? Phase difference ke liye. The condition for constructive interference is given as n into 2 pi, where n goes from 1, 2, 3, 4, so on and so forth, both plus and minus. And for destructive interference, it is n minus half into 2 pi. Again, n it goes from plus 1, plus 2, minus 1, minus 2, so on and so forth. So this is the formula which we have for the phase difference. The previous formula which we have derived, it was for path difference. So I hope you have understood this particular point. We again, I'm telling you, we are going to use this particular point as well. So we are going to use this particular formula whenever we go for solving numericals. Okay. Any doubts till this point? Bolo re yes or no? Okay. Now moving forward. Now till this particular point, we have seen the concept of path difference. We have seen the concept of phase difference. Now, what are the important points which we need to remember with this particular chapter? Now, this is very important. So, there are certain important points which I have given over here. So, the first one, what is the condition so that the interference pattern will be visible clearly on any particular screen? Okay, so that is the condition which is given over here. What is that condition? The D should be very greater than D. Once again, what is big D? Big D is the distance between the slits and the screen. So the distance between the slit and the screen should be very, very, very high than that of the distance between two slits. Now the actual values are not given to you, but generally if you observe in numericals, the value of small d, which is the distance between two slits. So the value of this is usually given in millimeters. So you can imagine how small the distance between the two slits can be. As opposed to that, the value of big D, which is between the slit and the screen, is usually given in meters. So you can see that big D is much larger than that of small d. Okay. Second, now when we consider the location of fringes, obviously we assume that the sources are coherent. Then and then only we can see the interference pattern. So that is very important. The two sources must be coherent. Means what? They should be in phase. We assume the location of fringes based on this condition, that they are in phase and they are coherent. Okay. Now, if by chance in considering practical aspects, if there is a non-zero phase difference, ideally if they are in phase, then the phase difference should be 0. But if there is non-zero phase difference, then it should be added appropriately. Okay. Now, generally, we don't have the practical aspects of adding the phase difference. What generally is done, either it is added to S1 or it is added to S2. And then they are both adjusted. Or sometimes it is also done that the 50% is added to S1 and 50% of it is added to S2. So that addition should be done by chance if there is some phase difference and they are not actually properly coherent. So what will happen if there is a phase difference? If they are in phase, no issues, कोई problem है ही नहीं, there won't be any problem. But if there is a non-zero phase difference and it is added, then the entire pattern, fringe pattern, will shift than its center point. Means let's say on the screen, if this is where the fringe, central fringe was supposed to be formed, then it might shift a little bit and it might form over here. But that does not mean that the width of fringe changes. Fringe width does not change. See, this is very important. It will not change fringe width. It will just change the location of it. बाकी कुछ नहीं होगा. मतलब स्क्रीन के एग्जैक्ट सेंटर में आ रहा था, वो थोड़ा ऊपर नीचे आगे पीछे इधर कुछ किधर तो भी होगा. बाकी का पैटर्न विल बी एग्जैक्टली सेम एज दैट ऑफ बिफोर. ओके, सो एनी डाउट्स इन दिस? बोलो यस और नो. ये सब पॉइंट्स समझे हैं व्हाट एग्जैक्टली इज हैपनिंग? Okay, good. Now, okay. Okay, one more time. Which point? 1, 2, 3, 4? One more time. Which one? First point, second, third, or fourth? Okay, third. ठीक है. Once again, third and fourth point. If these S1 and S2 are not in phase, means there is some phase difference which is non-zero. It can be anything. So that phase difference needs to be adjusted. Now, how it can be adjusted? By adding it. How to add it? Again, we don't worry about that. Either you add it to S1 or S2. उसके वजह से क्या होगा? If we are getting a pattern at this particular point, let's say this is where the pattern it's supposed to start from center band. So this entire pattern, instead of starting at, let's say, position A, it starts or it is formed at position B due to the non-zero phase difference. But that does not mean the widths of fringes will change. वो तो सेम ही रहेगा. सिर्फ पैटर्न यहाँ पे जो फॉर्म होने वाला था उसके जगह पे वो यहाँ पे फॉर्म हुआ, थोड़ा सा शिफ्ट हुआ. Maybe in this direction, or it might go to other direction as well. It might go a little bit upward, it might go a little bit downward, or it can go आड़ा टेढ़ा किधर भी. That is the only difference which happens. That this was actual position A, but it shifts due to the non-zero phase difference. That's it. ठीक है? Okay, single slit. So you will get a band which is comparatively bigger. Okay. Okay. So if we have only one slit, मतलब एक ही opening है, so you will get a band which is comparatively bigger. So दो slits होते हैं तो क्या होता है? उसी में तुझे दो band मिलेंगे due to two slits. अभी तीन होता है तो क्या होता है? In the same area you will get three slits or rather three bands. मतलब अज्यूम कर तुझे यहाँ पे ये पूरा का पूरा ब्राइट मिला, उसके बाद डार्क मिला, तो इंस्टेड ऑफ दैट यहाँ पे तुझे ब्राइट और डार्क ऐसा मिलेगा. फिर वापस इसमें तुझे तीन बैंड मिलेंगे, ब्राइट डार्क ब्राइट ऐसे मिलेगा. Basically what happens, as the sources they go on increasing, the bandwidth it goes on decreasing, and interference pattern it looks comparatively separated. तो spacing उसका बढ़ जाता है, बाकी कुछ नहीं. ठीक है? And basically what does it mean? That there is a difference in intensities. तो इनसे इंटेंसिटी डिस्ट्रीब्यूशन हम लोगों ने ऑलरेडी किया था वेव्स में. वेव मोशन में द सेम इंटेंसिटी डिस्ट्रीब्यूशन we have over here as well, right? What is light? Ultimately it's a wave, na? So In case of that particular wave, intensity will be distributed as for any wave for that matter. We have already seen this intensity distribution. Let's assume we have two waves. This is y1 and this is y2. Clearly you can see there is a phase difference. Just like before I told you, non-zero phase difference we have over here. So the superposition interference में what we will get? The collective displacement, which is y1 plus y2. एंड उसको कलेक्टिवली हम लोगों ने डिराइव भी किया था. वी गॉट द फॉर्मूला a sin omega t plus theta, where a is the amplitude of the resultant wave. This we have already done in wave motion. So the formula for the amplitude as well we have seen, which is a1 square plus 2a1 a2 cos phi plus a2 square. ये भी हम लोगों ने देखा था. थीटा, थीटा क्या दिखाते हैं तुम लोगों को? रिजल्टेंट फेज डिफरेंस देता है तुम लोगों को. ओके, which is given as tan inverse of a1 sin phi upon a1 plus a2 cos phi. Okay, again इसका derivation we don't have to worry about. Just keeping in mind the important terms which we have, a is the resultant amplitude and theta is the resultant phase angle. The same thing it happens in case of waves of light which are undergoing interference, and the resultant interference pattern which we are considering, or the resultant wave, is SHM. I hope you know what SHM is. SHM stands for simple harmonic motion. Okay. So just like before, we can have intensity distribution for light waves as well. How we can have intensity distribution for light waves? Let's see that. For the intensities, we can go for maximum and minimum intensity. तो maximum intensity कब मिलता है हम लोगों को? When there is no phase difference. Bright fringe जिसको हम लोग बोलते हैं, the bright band which we are seeing. Okay. Now bright fringe में phi मतलब waves they interfere in phase. Ideally this is how it should happen. So we know the formula that intensity is directly proportional to the square of amplitude. This is what we have already seen, a1 plus a2 ka square, where a1 is the amplitude of first wave and a2 is the amplitude of second wave. That is the maximum intensity which we have. Minimum intensity kab milta hai? When angle is 180, they are completely out of phase, exactly opposite to that of one another. So I mean can be given as a1 minus a2 ka square. Now for constructive interference, the maximum value which we get, constructive interference means bright fringe, we get the maximum intensity is 4 times that of original intensity. Whereas for the destructive interference, which is dark fringe, we get minimum value which is 0 intensity. That's why we call it as a bright and dark spot. No? Bright spot means what? We have highest intensity, maximum intensity. And dark fringe means we get lowest intensity, which is 0. Now, keeping in mind, this is applicable only for narrow slits. The size of slits should be very, very, very narrow. It is generally given. The width of slit itself, it is maybe in micrometers or max to max millimeters. Clear? Any doubts in this? Bolo yes or no? Okay, good. Now, looking at the next part, what we have, we are going to deal with intensity distribution itself. Okay, but it is related with the electric field which we need to consider. Now, what happens in case of narrow slits? Narrow slits, you get a proper distribution or interference pattern. But what if we have slits which are comparatively wide for wide slits? If the width of the slit is comparatively bigger, for wide slits, the interference pattern we get is very blurred. Means we are not able to see proper distribution of bright and dark fringes. They might be mixed together. We don't get complete zero intensity, and we do not get complete maximum intensity. We get a blurred pattern with a poor contrast for that matter. Okay. Now, next part, we have intensity at point P with reference to the electric field which we have. Now, electric field, obviously, it is keeping in mind electric field, it produces light. So that is the basis which is considered for that. But for that to complete, it will take around 10-15 minutes, which is, we don't have that much amount of time which is left right now. It's almost 8:20 and I need some 10-15 minutes to properly cover that part. So today I'm not covering the next part. We are going to stop over here only, just to avoid confusion in the next lectures, to have a proper flow of the lectures which we have. Okay. So today we'll stop over here. Once again, before going, whatever we have done today, is it clear? We have seen very important formula today. We have seen very important formula for intensities. We have seen important formula for path difference. We have seen important formula for phase difference. We have seen the relation for path difference and phase difference for both bright as well as dark fringes. Keeping in mind that the formula for bright fringe and dark fringe, they are totally different. We have seen the formula for bandwidth, which is fringe width. So today, apart from understanding, we had a lot of application based understanding as well. Means we are going to apply those formula as well when we go and solve some numericals. Okay. So once again, before going, please do let me know whether you have understood today, yes or no. Okay, good. Okay, before I go, once again, only 2-3 students are sending me notes on regular basis. Asmita, she sends me on regular basis without fail. नीरज ये बार भेजा था उसने रेगुलर, ही इज सेंडिंग कंपैरेटिवली रेगुलर. कल्याणी मैडम ने आज भेजा था. बाकी के लोग, यू हैव नॉट सेंडिंग मी नोट्स whether you have written or not. Okay, Shubham, Ayush, Supriya, Kiran, you are not sending me your notes. So I expect before next lecture, I want all of you to send your notes to me, whether you have written it or not. Properly picture nikal ke send it to me. I'm going to check it. I have already checked it. जिसने जो जो भेजता है मैं सब पढ़ता हूँ. I glance it, I read it if time permits. I want all the notes to be sent properly. You do have my number. You are in a group. WhatsApp पे भेज दो. जब भी time होगा मैं देख लूँगा. I'll go through that. Okay.